So there are two types of methods, right? What are those? That is line of code and functional count, right? Two common methods for size estimation is line of code and functional count. See, please listen carefully. Okay, I'll discuss it one by one. Before that, as I already told you, what is a size estimation? Size estimation is nothing but you are identifying the size of the project, the total size of the project. So because of that, what you can do is the size estimation allows for estimation effort, time scale, total number of faults. Okay, so all these things you can able to identify. That is the estimation effort means what, right? How much can you have to estimate? What is the cost of it? What is the development time? Right? All these things can be identified. That is the estimation effort. Then time scale, how much time it will take to complete the project. Total number of faults. Once you identify the size, you can able to identify how much, how many number of faults will be occurred. All these things you can able to identify if you are exactly identifying the size estimation. So there are two methods to identify the size estimation: line of code and functional count. First, we'll see line of code. Please listen carefully. Right? Very important. Line of code. What do you mean by line of code? Right? Line of code is any line of program, right, that is not comment or blank line, regardless of the number of statements on the line. Okay. So what do you mean by line of code? Just you are going to count each and every line of your code. That is what is called as your line of code. Okay. So it includes all lines containing program headers, declarations, executable and non-executable statements. All these coming under line of code. Okay, it just takes an example, right? Let us take an example. So this is a code which I pasted here, right? So I'm going to find the line of code, right? I'm going to find the line of code. That is the size of this code. Okay. So total number of lines, how many it is? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code are there, right? So here in line of code, there are 2 lines, right? Which is blank. 3 is blank, right? And 4 is what? It is comment. So what actually explained in this particular, what is that point? Not comment or blank line. You are not going to take the comment. You are not going to take the blank line, right? So you have to exclude or avoid line number 3 and line number 4, right? Because line number 3 is blank. Line number 4 is having the comment, right? So the total number of lines here is 8. Okay, so this is what your line of code. Very simple, right? It's very straightforward, right? If you are having if you want to find the size of a project, right? You have to simply count the number of lines of code, right? So here in this example, it is 8. Okay, you may be asking, sir, we haven't even started the design. We haven't even started the implementation part. Then how can we calculate the code, a line of code of it, right? Line of code. How can we calculate it, right? So how they are calculating, right? So they are actually taking, because similar kind of projects which is already available previously. For example, say in almost all the project, most of the project, right? Website designing project or web application project, we'll be having a login. We'll be having a login. So login is already developed for other websites. The same thing we are going to deploy here. So you'll be able to identify how many lines of codes will be there, right? So line of code means it is actually calculating the lines of code which is already implemented for some other project, which we are going to directly use it, right? So line of code is actually which is already, the code is already available for other projects. That project we are going to use it here, right? So that is what a line of code means. You are counting the number of lines, right? Counting the number of lines. Okay. Let us see what are the advantages and disadvantages, right? So this line of code concept is actually universally accepted because we have so many number of projects nowadays, right? We are actually reusing the what is that, codes, right? We are actually reusing the codes. Right, so for login, already code is available. Logout, already the code is available. Right. Likewise, some basic major blocks are there. Right. so that we can easily reuse it. So we can able to identify the lines of code. So it is universally accepted and is used in many of the famous model COCOMO. That COCOMO model we are going to discuss in the next class, right? So universally accepted and is used in many models like COCOMO. Estimation is closer to developer's perspective because you are actually counting the lines of code which the developer is going to implement, right? So the estimation will be very closer. There won't be any what is that changes. There won't be any changes. If you are estimating for 2 months, that 2 months will be exactly perfect. It won't go beyond that. It won't go what is that before that. So estimation is closer to the developer's perspective. Okay, simple to use, right? You can easily count the number of lines, right? So it is simple to use. So these are the advantages. Now, what are the disadvantages? So disadvantages is different programming languages contain different number of lines. Is it right? Because, for example, say that login part is actually developed using, say, C#, C#.NET. Okay. So if you are going for some other language, say Python or say Java, right? So it will be having different number of lines, right? So this particular line of code concept is language dependent. It is language dependent. That is why the first disadvantage is different programming languages contains different number of lines. Okay, so no proper industry standard exists for this technique. There is no proper industry standard. There is no standard is available. Okay, so it is difficult to estimate the size using this technique in early stages of project. Say, for example, if you are going for a project which is completely new, it is completely new. So that project you haven't done it previously. It's very new. For example, say artificial intelligence. You are going to implement a project which is called as an artificial intelligence, right? Which you have done it, haven't done that previously. Then you have to code it new, right? You have to code that particular part newly, right? So at that particular time, you won't be able to find the size of the project, right? You won't be able to find the size. You won't be able to estimate the size. So it is difficult to estimate the size using this technique in the early stages of project. Okay, and then line of code is language and technology dependent, right? As I already told, line of code method is language dependent. C#, Java, right? So it is language dependent and technology dependent. Also, it is based on the technology. So if you are going for, say, a technology like RPA, right? RPA will be having a different line of code. So the technology is different, right? So line of code language is actually technology dependent. Okay, so you cannot able to apply this line of code for all the technologies, right? If you are using the if you are using the line of code, then the technology should be same for the project which you are going to implement, right? Which is already implemented. So all these things it is dependent. Okay, so these are the four main, very important. The disadvantages of line of code, right? Most of the time in the university examination, right? They'll be asking. Right? Fine. So this is what your line of code. So what is a line of code? Line of code is simply counting the number of lines. Okay, excluding what? Two things. What are those? Blank spaces, and what is that? And comments. These two things you have to exclude it. All the lines you have to count it. That is what your line of code. So to overcome these disadvantages, right? We are going for another method which is called as functional point analysis, right? Functional point analysis. Okay. It is also called as functional count. We are going to count the number of functions. So in a particular project, how many number of functions are available? That you can count it, because you are not going to count the number of lines. You are going to count only the functions. That is what is called as functional count. In other words, it is called as functional point analysis. Both are same. Functional point analysis. Okay. So the functional count is appeared to be a solution to a size measurement problem. Right. What is the solution? What is the problem? These are the problems which we discussed in the LOC. Right. To overcome these difficulties, right, the disadvantages, we are going for functional point analysis. Right. So what are the special features of this functional point analysis? It is independent to the language. Previously we discussed, right? It is dependent on language, dependent on Java, dependent on say C#, right? Dependent on say C, C++. So it is dependent on languages. But here in functional count or FPA, that particular method is independent to the languages. Second point is estimate development effort in early phases. You can able to easily identify the development effort, how much effort you have to put for developing this project. That you can easily estimate it, right? Then directly linked with the requirements, right? Directly linked with the requirements. What we can do is based on the requirements, we can identify the functional counts. So it is directly linked with the requirements. So these three special features are there for function count, right? Okay. So what is the principle of functional point analysis or functional count, right? So the principle of functional count or principle of FPA, functional point analysis, is decomposed into functional units, right? Functional units. What are the functional units? There are 5 functional units, right? Let us see one by one. Input, right? Input is one functional unit. What is that? Information entering the system, which is called as the input. What is an output? Information leaving the system. Okay, that is what your input and output. And then inquiries, right? Request for instant access information, right? Request for instant access information. You are giving a request, right? Using the inquiries, what actually you're doing? You are going to access the information, right? For that you are giving the inquiries, right? Which is already available inside the database, right? That is what your request for instant access information. Then internal logical file, information held within the system, right? So where the files are stored, So the files are stored internally inside the, say for example, RAM, internal logical files, right? So system files are available inside the RAM. That all are called as internal logical files. What is external logical files? Information held by other system that is used by fine. So external logical files, what is that? It is the information held by other system that is used by system being analyzed, right? Other system is what? Say hard disk, CDs, right? So all these are external logical files. So inside the hard disk and inside the compact disk, right, you'll be having some files. That files you can call it as external logical files. So you are going to access that logical files, right? Fine. So these are the 5 functional units of FPA, right? So it is represented in a diagram now. Please check it out, right? So the functional point analysis can be divided into 2 types: transactional functional type, data functional type. So what is a transaction? Transaction means what? You are going to do some data transfer, right? That is the transactional functional type. So first one is external input, right? Input I told in the last one, right? The principle, no? So that is where external input, right? So external input, right? Input from user to the particular logical files. It may be the internal logical file or external interface file, right? So external input to ILF or EIF, okay, fine. And then external output. So you are accessing those files and that is sent to the user. That is your external output. And then external inquiries, right? So user will be asking some inquiries to get the information, right? User will be asking some inquiries to get the information from internal logical file or external interface file, right? So user will be asking and he will be getting the information. That is why bidirectional it is there. It is bidirectional. We are giving, user is giving the inquiries and the information is getting from the ILF and EIF. Okay, this is ILF and EIF. Okay, fine. So here you can able to see bidirection. Here also you can able to see bidirection. That is what your external inquiries. Okay, and then Second one is what? Data functional type. In that, internal logical file. This is your internal logical file. And other things, hard disk, CD, all are external interface file, right? So from external interface file, the files are transferred to the internal logical file. That is why EIF. The arrow mark is directly sent to this particular ILF. Okay. So from ILF, it is sent to the users. Okay. So this is your principle of FPA. Okay, this is what happened. Okay, you may have studied very well in detail in computer organization architecture, COA, right? So this is a simplified version of that. Okay, fine. Okay, so now how to calculate? See, because in the previous discussion in LOC, we are directly counting the number of lines. We are directly counting the number of lines. But here, how to count the functional points, right? There we have some calculations. Very important. Please listen carefully. If the university is trying to ask a question which is very difficult, they can ask this. But what I tell is that it is very easy, very simple, right? So please listen carefully. Okay. So until this, whether you understood or not, until this, what is a line of code? How to calculate the line of code? What is a functional point analysis? Right? Until this, you have understood, right? Yes. Okay. Yes. Okay. Only 2 years, no issues, right? So I'm recording the session, right? You can please check it out once again, and you can able to identify. Akshay Gabras, very good, fine. Okay. So now let us calculate the functional count. Functional count or functional point analysis. So how to calculate it, right? So how to calculate? There are some formulas, very simple formulas, right? I request you to just follow the steps, right? For the time being, don't worry about what is this unadjusted function points, what is this complexity adjustment factor, what is this value adjustment factor. Don't worry about it. For the time being, you please understand or follow what are the steps I am telling out. Okay, fine. To calculate the functional count, to calculate the functional point analysis or functional count, there are some steps, right? So 2 steps are followed. What is that? First one is calculate the unadjusted function points. That is the first step. The second step is calculate the complexity adjustment factor, CAF, right? And another one is value adjustment factor, VAF. Both are same. But the examination, right, sometimes they'll be asking CAF, sometimes they'll be asking VAF, right? So don't confuse with this, both are same. Complexity adjustment factor, value adjustment factor, right? Fine. And how to calculate this UFP, right? Let us see what is the UFP, right? And then how to calculate the CAF. For calculating the CAF, this is the formula. 0.65 plus 0.01 into summation of Fi. Summation of Fi. Okay. What is the summation of Fi? Let us discuss. Don't worry. Right. First, we'll discuss how to calculate the UFP. How to calculate the UFP. Then we'll discuss how to calculate the CAF. Right. If we calculate these 2 things, we can able to calculate the functional point analysis, because functional point analysis is equal to UFP into CAF. That is a formula. Please don't forget this. Right. Fine. So these are the steps for calculating the functional point analysis, right? Okay. So now, let us see this particular point. I told you, right, 5 principles, right? 5 principles, okay? What are those? External inputs, external output, external inquiries, internal logical files, and external logical files. These are the function type, right? These are the function type, okay? Because in a project, you need to have an input. You will be giving an input, right? That is mandatory, right? And you'll be getting an output, right? That is mandatory for any project, okay? And then for getting the output, right, you may be accessing some files, right? So that is what your external inquiries, and you will be accessing the internal logical files. You will be accessing the external interface files. So all these things will be there, okay? These are mandatories. Right, that is why it is the functional type. Okay, so for all these things, what are the weighing factors? What are the weighing factors, right? So normally in the question, the examination, right, they'll be giving all those values. No need to memorize this. Okay, fine. So for the time being, or for this particular explanation, right, I have given few values. This is actually common. Normally, right, almost all the books, textbooks, right, they'll be giving these values. This is common. So in the examination, most they'll give the values. Don't worry about it. I'll explain you what is the meaning of this, right? So this is the function type already told. External inputs, external output, inquiries, logical files, interface files. So all these are the functional type. So for this functional type, what are the weighing factors? What is the weighting factors? Right? Weighting factors means the what is that? Weighing factors means complexity. What is the complexity for this? Right? Say for example, external input. If the complexity is low, right? If the complexity is low, the weighting factors is 3. Right? The weighting factor is 3. If the complexity of the external input is average, if the complexity of the external input is average, then what is called as it is 4. Right? Likewise, if it is high, it is 6. For external inputs, this is the weighting factors, right? Based on the complexity, So likewise, external output, right? For low it is 4, average it is 5, high it is 7, right? So this is nothing but the complexity levels or complexity, what is that? Weighting factors, right? So the for external inquiries it is 3, 4, and 6. For internal logical file it is 7, 10, and 15. External interface file it is 5, 7, and 10. So likewise, we have given the weighting factors or complexities. Okay, complexity values. Okay, right. So this, please just understand what is the meaning of it. Okay, the weighting factors for each type. What is that? Functional type. Based on their complexity. Are as follows. Right? Are as follows. Okay. Fine. Let us discuss an example, right? To understand what is an unadjusted functional point and what is a CAF. Okay. Just consider a project. So that project is having 10 number of inputs, external inputs. 10 numbers. 10 inputs are there. Okay. 10 inputs are there. Then EQ. EO. What is EO? External output. What is external output? Here in this case, 13 number of external output. The user is receiving 13 number of external output. Okay. EQ4, EQ2, ILF2, ILF9. All these are counts. And within the bracket, what they have mentioned is it is low complexity. For this particular project, it is low complexity. Okay. For external inputs, how many inputs are there? 10 inputs are there. And what is the complexity? Low complexity. Now what we have to do? 10 into 3. What is 3 here? Low complexity. Low complexity means what? Low. This is low here. And what is the value here is 3. For external input, for low complexity, the value is 3. So here we are making it as 3. So 10 into 3 is equal to 30. Okay. So 30 is the value for the external input. Likewise, for external output, 13, and it is high complexity. So external output 13 high complexity means this is the high, this is external output, it is 7, right? So now 13 into 3, 7, that is 91. So likewise, we are calculating for all the types, functional types, right? So let us see this, the third one, external inquiries. So 2 are there, external inquiries is equal to 4, external inquiries is equal to 2. This 4 is having average complexity. This 2 is having high complexity. Then we have to check it out. For external inquiries, 4 is having average complexity. What is average complexity? External inquiries average is 4. External inquiries high is 6. Is it right? So now 4 into 4 is 16. Likewise, for external inquiries, 2 is having high complexity. That is 6. Okay. So 2 into 6, 12. So likewise, we are calculating. The number of inputs with multiplying with the complexity values, so that you can able to identify the number of weighting factors for each external values, right? Each values, right? So 10 into 3 is equal to 30 is for external input, 91 is for external output, 16 is for external inquiries, 12 is for external inquiries high complexity, 20 is for internal logical files, 45 is for external input files. So all these we have calculated. So if you are summing up all these things, you will be getting the UFP, that is 214. What is UFP? Unadjusted function points. See, all these things you won't be able to adjust it. You cannot say convert the high complexity to low complexity. It is high complexity. You cannot able to change it. You cannot able to convert the high complexity into average complexity. That is why it is called as unadjusted function points. Unadjusted function points, right? So these 5 function types are unadjusted. Okay, so we are identifying the complexity and we are calculating the values for that each function type, and finally we are summing up all the values to identify the unadjusted function points, UFP. So now we have identified the unadjusted function points, which is equal to 214. Now what we have to do, we have to calculate the CAF. What is CAF? Complexity adjustment factor. Complexity adjustment factor. So for that, what is the formula we discussed? 0.65 plus 0.01 into summation of Fi. So we have to calculate the summation of Fi. So what is summation of Fi? Right? What is summation of Fi? Summation of Fi is total complexity adjustment value, right? So don't worry about what is that complexity adjustment value, right? I'll tell you that. Just remember a scale. You have a scale with you, right? So in that scale, 0 represents no influence, right? 1 represents incidental, 2 represents moderate, 3 represents average, 4 represents significant, 5 represents essential. So this is the total complexity adjustment value, right? See, we have discussed 2 things, right? The first one is unadjusted function points. You won't be able to adjust it. You won't be able to adjust it. And the second one is what we discuss is complexity adjustment factor. What is the complexity adjustment factor? You are going to adjust the complexity adjustment factor, right? You can be able to adjust it, right? That is why we have given the scale of it, right? For 0, no influence. For 1, incidental influence. 2, moderate. 3, average. 4, significant. 5, essential, right? So this is the scale you have, okay? So now, how this sigma Fi or summation of Fi is calculated, right? You will be asking some standard questions. For example, say in this project, right? The project which you are going to develop, right? Require backup recovery. Yes, you require a backup recovery, right? Likewise, you'll be putting some questions, standard questions. Whether this project is having data communication, yes, it is required. Distribution processing required, yes, it is required. Any performance is critical, yes, many performance is critical. Online data entry is required, yes, online data entry is required. So likewise, we'll be asking some standard question. So from this standard question, we can able to identify the what is that range. So for example, whether the system require backup recovery, yes, then how much it is? Then we have to go for the scale, right? 3 is the average. Yes, average we need to have, right? That is F1 is equal to 3. Whether data communication is required, yes, data communication is required. So how much it is required? So go to the scale. 2 is moderate. So moderate data communication, moderate is required. So 2 is enough. And distribution processing is required. Yes, distribution processing is required, but not much. So 2, moderate. Okay. And any performance critical, yes, few performance may be critical, right? So for that, what you are giving? Significant, right? Sorry, essential. It is essential. Then all data in this record, yes, it is required. So 3 is average. So likewise, you will be asking some standard question, and from that, what is the Fi? What is the total complexity adjustment value? Whether it is 0 or 1 or 2 or 3, you are going to identify it, right? So once you identify these values, then what you can do is you can just calculate it. You can just sum it. That is why summation of Fi. 3 plus 2 plus 2 plus 5 plus 3. That is what we call as 15, right? So now you have identified the total complexity adjustment value. Okay, that is summation of Fi. That is, you have identified this value. Now you can easily calculate this because 0.65 plus 0.01 into summation of Fi. We'll be able to identify the CAF, right? So now CF is identified. CF is 0.8. Now what is total FPA? What is total FPA? Total FPA, this is your total FPA, right? So total FPA is what? UFP. UFP already identified. What is UFP? 214, right? 214 into 0.8, that is 171. This is your total function point analysis. So what is 171? 171 number of function count is there in your project. Very simple, right? 171. What is that? Function point, functional count is available in your project, right? So with the help of this particular value, you can able to identify the number of functions, right? Today, what actually we are going to do is we are going to discuss a simple scenario, right? So in the last class, we were discussing about functional point analysis, right? So we're discussing how to calculate the functional point analysis. Let us recap that, and then we'll come back to the scenario, right? Which is left out, right? It's this class. So what I'm going to do is I'm going to recap what we have discussed in the last class. So to calculate the functional point analysis or functional count, so the two steps are there. We have to calculate the unadjusted function points, and then we have to calculate the complexity adjustment factor. For calculating the functional point analysis, we have to multiply UFP, that is unadjusted functional points, into complexity adjustment factor, right? And once it is multiplied, and you will be getting the functional point analysis or functional count. What is functional count or functional point analysis? The number of functions to be taken out or to be carried out in the project. That is the size of the project. Okay. So to calculate the UFP, what actually we have done is using this method, we have calculated the UFP. That is the number of inputs into the complexity level, right? Number of inputs into the complexity level. So how it is calculated? Number of inputs for each and every principles, right? We have discussed about 6 principles, right? Input, output, inquiries, ILF, ELF, right? So these things we have discussed. Based on this principle, we are actually calculating the UFP, right? So in the example, we have discussed about what is EI, external input, how many number of external input is there, and what is the complexity level, that is low. If it is low, then we will be taking 3. If it is average, we will be taking 4. And if it is high, we will be taking 6, right? So likewise, for each function type, we were calculating the total UFP, unadjusted function point, okay? Right, so likewise, we'll be calculating the UFP, and then we'll be calculating the FI. So what is FI? FI is what? Total complexity adjustment value. FI is total complexity adjustment value. That is nothing but a scale of responses, right? If, for a particular standard question, what kind of responses you are taking, okay? See, here we have taken some 5 standard questions. Just a system acquire reliable backup recovery. F1 is equal to 3. We have taken it is, yes, it is moderate. Sorry, it is average, right? So likewise, for this particular standard query, what is the level of complexity adjustment value? Whether it is 0 or 1 or 2 or 3 or 4 or 5, right? Okay. So based on this, we are calculating the FI, right? FI is 15 here. So from this, we will be able to calculate the FPA, right? 0.65 plus 0.01 into 15, right? We'll be able to calculate the CAF, and multiplying UFP and CAF, we'll be getting the value as 171. What is 171? The total number of functional count, right? This is equal to the total number of functional count, right? That is your size of the project. Okay, fine. So this is what we have discussed in the last class. This is just an example, right? So how the question is, right? So I have taken the question from this particular website, right? So this is a website. So it's a very good website. You can just check it out. All the explanation will be there. This website is all having all the explanation what we have discussed, right? Is there, and they have explained a scenario, right? So let us discuss that scenario, and then we will move on to the next topic. Okay? Right. So the question they have asked is, calculate the functional point or functional count. Both are same. Okay. Calculate the functional point, function point, productivity, documentation, and cost per function. So this productivity, documentation, and cost per function we haven't discussed. So I have just typed it out, but we have to study it how to calculate. Okay, in the coming class, that is when we are discussing about the cost estimation, we are discussing about the COCOMO model, right? COCOMO model, right? So in that we will be discussing about all the cost estimation part. Okay, so for the time being, I'm not going to take this particular part. So until this, what we discuss is how to calculate the size of the project. That is the function point, right? Functional count. Okay. So calculate the function point for software application with multiple processing factors. Multiple processing factors 5, 1, 0, 4, 3. All these values they have given. So processing factors. What is this multiple processing factors, right? So in the previous case, we have taken these things, right? Does the system require backup recovery? Is the data communication is required? Whether the distribution processing is required? These are some of the standard questions, right? So in the scenario, what they have done is they have taken the processing factors, right? They have asked the standard questions and they have given the values. They have given the values. So in our case, this total complexity adjustment value, right? It is already given. This is what your total complexity factor. So what we have to do, we have to add all those things, right? To get what? Fi, summation of Fi, right? This is what your summation of Fi, right? And the number of external input is the average complexity. Number of external output, right? It is low complexity. The number of external input, high, it is 6. The number of ILF, internal logical file, the complexity is average. The number of external logical file, the complexity is low, right? So, likewise, you have given the values. So from this, what we are going to do is we are going to calculate the function point. Okay. So what are the input data they have given? They have given Fi, right? What they have given? Sorry, the given data is Fi. They have given Fi. What is Fi? Fi is all these things. That is summation of, right? Summation of all these things. Okay. Right. So Fi they are given. Then what they have given? All the values of external input. So external input they have given, right? That is 22 external input is there. That is having average complexity, right? So all these are given data, right? And external output, what is the number of external output? 45 numbers are there. What is the complexity? Complexity level is low. Okay. Likewise, for external input they have given. So here external input average they have given external input high complexity. How many numbers are there? 6 numbers are there, right? So likewise, the number of ILF, right? So that is the number of ILF is 5. Internal logical file is 5. And the complexity is average. Like that they have given. So from this we can able to calculate the value. So let us see how it is calculated. So we all know what is FPA, functional point analysis, UFP into CAF. Okay, unadjusted functional point, right? And CAF, right? So these things we have to calculate. So how to calculate UFP? UFP is 22 into 4. What is UFP first? You have to take all the external input, external output, ILF and ELF, right? So first thing is EI, average, external input average. So EI is 22. 22 is taken, right? EI is 22. And what is the complexity just mentioned? It is average. What is average here? It is 4. That's why 22 into 4 plus What is the next one? External output. External output is what? 45. And the complexity is low. So 45 into, sorry, it is 5. I made a mistake. Okay. So it is low, right? Right. So the external output, the complexity is low. So low means what? It is 4. Right. I made another mistake. It is 4. Right. It is 4. Okay. So now, external input high. External input high. Okay. So that is the number of external input is 6 here. That is having high complexity. So external input is 6 into high complexity is 6 because external input high complexity is 6. Right. So likewise for ILF it is 5. ILF it is 5 and the complexity is average. That's why it is 10. Likewise for ELF, right, it is 2 and the complexity is low. That is why it is 5. So by multiplying and adding all these things, we will be getting the value 409. So UFP, right, is 409 here. And we have to calculate what is CAF, right? So for this adjustment factor, right, that is a complexity adjustment factor, we have 0.65 plus 0.01 into summation of Fi. As I told in the previous slide, Fi it is already given. That is, they have created the standard questions and they have given the values directly in the question itself. Right? So CAF is equal to 0.60 plus 0.1 into summation of all the Fi. Right? You will be getting a value, right? So then we are multiplying it, we will be getting 450. So the functional count is 450. 450 functions are there in your project. So that you can call it as your size of the project. Okay, that is call it as your size of the project. Right? It's a very good example. So if you want, you can check it in your in this website, right? In this website, right? They have calculated the effort also, right? These things we'll discuss in the next coming class. Okay, fine. So the next topic is advantages of functional point analysis. So what are the advantages? Right. So as already discussed, functional point analysis is overcoming the problem of line of code, right? But line of code, so line of code, we won't be able to identify the number of lines because it is not actually started implemented. No. Right? If we have already implemented, then we can able to identify the line of code. But here, in case of this functional point analysis, don't worry about what is the number of lines, but the number of functions, right? The number of functions we can able to calculate it. That is what functional point analysis. What is the advantage of it? It enhances the productivity and workflow process of the software applications because you have identified the functions, right? So you can say, for example, for this 5 particular functions can be done by this particular employee who is good in developing the core part of the project. So like this, we can easily categorize and allocate the resources, right? So it enhances the productivity, right? Because we can able to, as fastly we can able to complete the project. So it enhances the productivity and workflow process of the software application. So workflow process, right? So until this particular point, we have to complete this. The next part, we have to complete this. Likewise, we'll be having a workflow process, right? So that process is also excellent in case of functional point analysis, right? It estimates the software application functional size. Right? We can able to identify the functional size of the software project, right? Because we are calculating the number of functions. No? So it clearly estimates the software application functional size. It estimates the development time of the software, of course, right? How much time it will take to complete all these functions. We can able to identify it. That is the development time. And also non-IT people, very important advantage. Non-IT people can also be able to understand the functional size. See, we can explain the client. The client may be a non-IT people, right? He may be IT people or he may be a non-IT people, right? So for them, we can able to explain, okay, this is the size of the project. We need this much of time to complete this project. We can able to convince them. That is why non-IT people can also understand the functional size of the application, right? It is a technology independent approach, of course, right? Line of code is actually a technology dependent approach, because each and every line, it is dependent on a particular technology, right? But in case of functional point analysis, it doesn't worry about what is the technology, right? So it is a technology independent approach, okay? And it estimates each functionality's cost of the software application. Very important point. We have identified the number of functionalities, right? So 450 functionalities it is there, right? So we can able to identify the cost of each functions, right? We can able to identify the cost of each functionalities, right? So these are the major advantages of FPA, right? And of course, there will be some disadvantages. And what are those? It is a time-consuming process, yes? Because see, these many calculations we have to do. See, we have done the calculation very easily, no issues. But the actual scenario in the industry, right? What we have to do is we have to calculate all these. We have to get all these standard questions. So, what are the questions we have to ask for the project? We should not miss any point of it, right? So, we have to get those questions. We have to answer those questions, right? And also, we have to identify whether how many inputs are there, whether it is low complexity or high complexity. It is going to be a time-consuming process. It is going to be a very big time-consuming process. That is why it is a disadvantage of this particular FPA. Right? It is a costly model of estimation. Yes, it is going to be a cost. When it is time-consuming, of course, it will be a costly model. Right? The accuracy of FPA is very difficult as multiple factors involved in it. See. Accuracy means what? We have 450, for example, say we have 450 functions. Okay, so we won't be able to finalize this is the final 450. This is the exact 450 functions. It may increase or decrease. The reason is the technology, right? We can take the technology, or we can take the coding, right? We may be writing in a different way of writing the code. Sometimes a particular function can be divided into 2 sub-functions. Right, that functions can be used in some other function. So likewise, some kind of issues are there, right? We won't be able to accurately identify the FPA. Okay, so yeah, accuracy of FPA is very difficult as multiple factors are involved in it. Okay, it requires a lot of internal, external parameters. See, some issues are there. Say, for example, we have used data to calculate all these things, right? We have used already available data to calculate all these questions, to frame all these standard questions. So in such cases, we require a lot of internal and external parameters. Like say, we may have missed some of the points in the standard questions, right? Because we haven't experienced that. We may be experiencing the future only. So if we are experiencing that issue in the future, we won't be able to, finalize it. Right, you won't be able to find it. These are the standard questions, right? So it requires a lot of internal and external parameters. Sometimes one particular one particular employee may leave the company. So we have estimated 450 functions and these number of resources, right? And within this particular time period, we can able to complete it. This is what we have estimated. But sometimes one person may go out, may leave the company. So at that time, you have to find another person, right? These are some of the internal and external parameters. And that parameters, internal and external parameters also depends on the company process, right? We have a company process, right? Each organization is following a process. That may also facing an impact, right? So there are lots of internal and external parameters or future areas. But all these things are right, it is solvable. We can able to solve it, right? So the FPA is having major advantages and it is having few disadvantages, but still we can able to solve these problems, right? Fine.